Here I've been given the tan ratio as -5/4, so slope is -5/4, so maybe it's going to cut through something like that. So it's got my negative slope, so I'm in, here's -4, +5. Here the slope is going to be +4, -5. Okay, so those are the positioning of those 2 points. So there are 2 different locations I have to consider. Now it says it's in quadrant 4, so I only need to worry about this one position. So I'm just going to highlight that it's only this position that we're really concerned with. Okay, so that's quadrant 4. So when I solve for this, actually first of all it says find the exact values of sine, cosine, tan. Okay, I know that it's in quadrant 4, so I don't need to worry about the quadrant 2 angle. So I'm going to solve for my triangle here. We're going to solve for my radius. So 5 squared plus 4 squared is going to be 41. So my radius is square root 41. And because I don't have to worry about this other angle in here, I'm going to just give one value for sine, one value for cos. Okay, so sine theta is going to be -5 over square root 41 because it's in quadrant 4. Cosine value is going to be +4 over square root 41 because it's in quadrant 4. Okay, if we didn't know the quadrant, there are 2 possible cosine values that we'd have to consider. So the reference angle here, we'll have to first find out the standard position angle. So we can use sine, cos, or tan to work out that ratio. So here, since we're given the tan, I'm going to use the arctan, and the input is going to be the ratio, the output is going to be the angle. Okay, so that's going to be θ1. So I'm going to do second tan of -5/4. That gives me -51.34 degrees. Okay, so I have to ask myself, is this in the right position? Is -51.34 degrees in quadrant 4, or is it the other angle here? And in this case, this is the correct angle. Okay, so that's the right position. Now I want to get in the habit of putting this into positive values. So my positive value is going to be 308 degrees, 0.66. 308.66 degrees. So these are equivalent positions. One is just the positive version of the other. So these are the same. Okay, these are both θ1. Now, we weren't asked for θ2, but we really should figure out what θ2 is and how to find it. So θ2 is on the other side of the circle. Okay, so I'm going to do this in a different color. So θ2 is over there. So θ2, I'm just going to either add or subtract 180 degrees from that angle. Okay, so adding 180 degrees just puts it on the opposite side of the circle where that slope would be. So this is going to be 128.66 degrees. And that's my θ2 position. And that's the wrong one. That's not the one I want, because I want the quadrant 4. So I'm just going to make sure I highlight that. These are both quadrant 4 angles. That θ2 is not. The last thing here, it asks for the reference angle. The reference angle then would be the angle in the triangle here. And that's going to be 51.34 degrees. Now really the reference angle is useful to give shape, but really we really want to make sure we're focusing on the position. It's in quadrant 4. That's very important, because if we just say 51.34 degrees, that implies it's in quadrant 1.